Hello everyone, welcome back my friends. Friends, today we are starting a new session with respect to UPSC Prelims 2025. This is a rapid revision session. Under this rapid revision session my friends, will be make you understand all the basics which are relevant for UPSC Prelims. With these basics, you will be able to solve any of the given question in the UPSC CSE paper which is going to come in 2025. This rapid revision session will be based on each and every subject. Say it your history, ancient, medieval, modern, environment, science and technology, economy and others. That is geography, all other topics will be covered under this rapid revision program. Now, this session will be focused on science and technology based rapid revision. This course follows like this. First, we'll be making you to understand all the basics which are relevant to the UPSC CSE for science and technology topic wise. Say your space, say your nanotechnology, say your robotics, say your information communication technology, say your defense technology. In this way, all the basics will be covered. Apart from the basics, the relevant current affairs for these basics will be said so that you can solve this exam at an ease. Now let's enter into our topic science and technology, and the focus for today will be the space. Under the topic of space, we will be discussing 5 important topics or 6 subcategories under this session. What are those 6 subcategories that you are going to discuss? Number 1, we are going to discuss what is an orbit and what are the different types of orbits around the earth. Now, number 2, we'll also learn the genesis of ISRO, how ISRO evolved, what happened with the ISRO, what ISRO is doing, and we'll also see labs of ISRO. What are the different laboratories with the ISRO? And in the third, we will see what are the different launch vehicles of ISRO. That is your PSLV, GSLV, that is launch vehicle module 3, and we will also see SSLV, and I will also give you introduction with respect to new generation launch vehicle, that is NGLV. Now the next thing that we are going to learn is what are the various missions of ISRO. Missions. We will also see different types of satellites. Along with the different types of satellites, we will also see the commercialization and application in the space. I will write C and A of space. These are the topics which you are going to learn. Apart from this, what is important from your exam point of view? These are first things you have to understand. These are the basic things you have to understand. Apart from this, there will be another session for the space in which you will be learning about universe. That is all the celestial object. Okay, all the celestial objects. Say your sun, what is happening on the sun, what is the life of a star. That is, sun is also a star, right? How do the phenomena in the star, in the space affect the satellite communications in the space or any of the component in the earth or on the earth. So in the universe, this is a very different topic. So that's why I made it a separate topic. Like for example, gravitational waves, or what is neutrino, what is a nebula, okay, what is a galaxy. These basic terms and definitions are very important because UPSC does ask questions in such topic also. Now let's go deeper into each and every topic that I have written here. Number 1, that is we are going to learn about the orbits. Now you might have seen in any figure or any picture since your childhood that all the orbits around the sun are in elliptical nature with sun at one of the foci of the given ellipse. Now you might have seen all the planets around the sun will rotate or revolve in the elliptical path. Is it yes or no? Yes, right? Now how does this ellipticity happen? This is based on your Kepler law. Okay, Kepler has given three important laws with respect to the orbits. The first law states that all the planets around the sun revolve in elliptical orbit. Understand these terms, my friends: revolution and rotation. Rotation is to turn around itself. This is rotation, to turn around itself. Revolution is to go around another object. See, if a planet is moving all through this path, that is called revolution. If a planet rotates around itself, that is called as rotation. Revolution and rotation are the basic terms you have to remember. Now the Kepler first law says that all the planets around the sun revolve in the elliptical orbit. And the Kepler second law, this is another very important law. Kepler second law states that if there is a line segment that joins a planet and the sun, it will cover equal areas in equal amount of time. For example, if this planet moves from January till February till here, let's say it moved till here in February, this area will be equal to the planet if it is moving from March to April. Let's say the planet was here in March, okay, and in April the planet is here. This area, that is, a line segment joining the planet and the sun traces equal area in equal amount of time or equal period of time. This is Kepler's second law. Now the Kepler third law, this is also a very, very important law. What does the Kepler third law says you that the farther the planet is from the sun, it takes more time to have one revolution. Okay, the farther the planet, the slower it moves. The farther the planet, the slower it moves. For example, in Earth, we take 1 year, that is 365 days to complete one revolution. Whereas Mercury, which is very, very closer to the sun, it takes only 0.2 years. What is 0.2 of 1 year? 1 year equal to 12 months. What is 0.2? That is 12 by 0.2, isn't it? Or 0.2 into 12. That is how much? That is just 0.2%, that is 2 by 10th of 12 months is the time that is taken by Mercury to have a one revolution. Whereas Pluto, which is today though not considered a planet, it takes some years to complete one revolution around the sun. Now when any object is revolving around the sun or any planetary objects in an elliptical path, it has 2 points. One point, this is called closest point, and another point, this is called as farthest point. The closest point is basically called as perigee. The farthest point is basically called as apogee. These two names are also important. Perigee is the closest point in any elliptical path and the apogee is the farthest point in any elliptical path. Now all these points I have tried to explain you through the slides. You can also get these slides from our Telegram channel. We will also try to share you all these slides so that you can keep on revising. So the Kepler's first law, the Kepler's second law, the relevant diagrams and also the Kepler's third law that I try to explain you is also based on the scientific data and the tabular diagram which shows you that the farther the planet, it takes more time to complete one revolution around the sun. One revolution is considered as 1 year on the earth. Whereas it takes for the Mars 1.88 years, almost 2 years. That is almost Mars takes 24 months to complete one revolution around the sun. So these are the three Kepler laws. Those are very, very important for understanding the orbits around the earth. Now the next point, I have also said you about perigee and apogee, the nearest point and the farthest point in any elliptical orbit. Now apart from this, one important concept that you have to understand is with respect to the gravitational pull of the earth. How does the satellite or any planetary celestial object does not come and fall into the earth all the time because of its gravitational pull? We all know that Earth has some gravitational pull. It keeps on attracting some other object in the space, right? But why doesn't a satellite in the space comes and fall onto the Earth all the time? Why doesn't moon comes and hit the Earth, though moon is very small when compared to the Earth? This is because of a force called as centrifugal force. Whenever an object is rotating or revolving at a higher speed, it exerts an centrifugal force, that is an outward force. For example, we have a washing machine in our house. How does a dryer work? When you on the dryer, the drum in the washing machine spins at such a higher speed that these clothes go and hit the walls of the drum, and the water in the clothes will come out through the pores or holes in the drum. This force that is exerted because of the faster rotation of your drum, which leads to the hitting of the clothes to the drum surface, is called as centrifugal force. The same force, this same centrifugal force will protect the planets to come and fall into the sun. Why doesn't Earth go and fall into the sun? Because Earth is rotating at such a higher speed that it doesn't go and fall, or it escapes from the gravitational pull of the sun. This is one important point that you have to remember. Why doesn't planet fall into the sun? Because of its revolution around the sun. Because of its revolution around the sun. Now these 2 points, hope you will understand. The rotation makes day and night. Rotation makes or gives day and night, whereas revolution gives you different seasons. Okay, what does rotation do? This is rotation. The day and night on the earth are because of the rotation of the earth, whereas revolution of the earth gives you different seasons, summer, winter, and etc. Now, when you are going to learn about the launch vehicles in this session itself in the future hour, one thing you have to remember is, when you are learning these launch vehicles or different types of communication satellites or Earth observatory satellites, you have to know in which orbits or where in the space these launch vehicles are going to put these satellites. So they are going to put at different orbits around the Earth. Any planetary object, my friend, say it Earth, Sun, or any other planetary or celestial object, it will have different orbits around it. Our Earth has 3 basic orbits around it, which I can divide into low Earth orbit, that I call it as LEO. Next is middle Earth orbit, that is called as MEO, and the other is high Earth orbit. High Earth orbits are basically greater than 35,800 to 36,000 kilometers. Middle Earth orbits are around 22,500 kilometers high, whereas low Earth orbits range from 200 to 2,000 kilometers high from the surface of the Earth. All these orbits are very important for you to understand and also solve most of the questions which are given in your exam. So this diagram gives you the classification of different orbits. First, number 1, low Earth orbits range from 100 to 1500. It might also range up till 2000, you can go. Whereas middle Earth orbit range from 5000 to 10,000, and high Earth orbits are basically greater than 36,000 kilometers, or basically from 22,500 to 36,000 kilometers. Now there are 2 important orbits I would like to make you clear. Those are geostationary orbit and geosynchronous orbit. These 2 orbits are very, very important. These are from the exam point of view, I am saying you, my friends, geostationary and geosynchronous. Geostationary, the other is geosynchronous. Now what is a geostationary and geosynchronous orbit? Now imagine this is our Earth, this is the equator of the Earth, this is 0 degree latitude, that is your equator. Any orbit which is parallel to the equator at a height of 36,000 kilometer from the surface of the Earth, which is also circular in shape, That orbit is called as geostationary orbit. Remember, an orbit which is parallel to the equator of the earth and circular in shape. Any orbit which is parallel to the equator of the earth and circular in shape, that orbit is called as geostationary orbit. The speciality of this orbit is, my friend, any satellite or any object which is placed in this geostationary orbit has the same time period of the earth. That is, this satellite will take 24 hours to complete one revolution in this orbit. If I place the satellite in this orbit, it will take how many hours to complete one revolution? That is to go and come again till this point, 24 hours. That is the orbital time period, 24 hours is equal to the time period of the rotation of the earth. That's why, my friend, any satellite which is placed in geostationary orbit will always remains to stay at one point. It looks that it is staying at one point, because if this satellite is at 8 am at this particular point, next day also this satellite will come and sit at 8 am exactly at that point. That's why any observer on the earth, if I am looking at the satellite like that, any observer on the earth, if it is looking at that satellite, and the next day if he looks the same satellite, he will come and sit here. So that's why any person on the earth thinks that this satellite is not moving. It appears to that it is not moving. So this is called as geostationary satellites. How many geostationary satellite orbits does Earth have? Geostationary orbit is only one, because only one orbit at a height of 36,000 km could be made, which is parallel to the equator and also circular in shape. Now, what are these geosynchronous orbit? At the same height, my friends, at the same height of 36,000 kilometers, at the same height of 36,000 kilometer, at the same height of 36,000 kilometer, if the orbit is not parallel to the equator but inclined to the equator like this, say this is your earth, if it is inclined to the equator like this, then that orbit is called as geosynchronous orbit. There could be n number of geosynchronous orbits. There could be n number of possibilities. Say this is our earth, this is our equator, this is one geosynchronous orbit, this is one geosynchronous orbit, this is another geosynchronous, this is another geosynchronous. So there could be n number of possibilities, whereas geosynchronous orbits are elliptical in shape. They are what, my friends? Elliptical in shape. These are circular in shape and these are elliptical in shape. These two orbits are very, very important, because all the communication satellites, what satellites, my friends? Communication satellites. All the communication satellites of the earth are placed in these two orbits. Very, very, very important topic. Okay. Hope you can remember these all points. We will go faster. Low Earth orbit. Low Earth orbit. What was the first principle we have learned in the Kepler laws? Kepler first law tells you that all the orbits around the sun are elliptical in shape. But what does the Kepler third law tells you? Kepler third law tells you that the farther the object, it takes longer time to complete one revolution. The closer the planet, it takes faster time to complete one revolution. The same principle is also observed here. In low Earth orbits, while I was explaining you about centrifugal force and centripetal force, that is, all the celestial objects like to pull you inside them, The sun is wanting to pull the Mercury, Mars, Venus and every other planet into it. In order to escape from the sun, what do? We revolve around the sun. In the same way, in order to escape from the gravitational pull of the earth, a satellite has to revolve around the earth. Now, the closer the satellite is to the earth, it should revolve much and much faster. The farther the satellite is from the earth, it should revolve slowly. Hope you understood. If this is a earth, the closer the satellite is to the earth, it should rotate faster, very, very fast. But if it is very, very far, if you say the satellite is in the farther orbit, it will move slowly. Now that's why, my friend, in low Earth orbit, we do not use it for communication purposes. Even though if we are using for communication purposes, we need large number of satellites in order to provide unprecedented communication. For example, the Starlink, which is basically an internet provision or internet service based satellite hub, which almost include 100 plus satellites, which is started by Elon Musk, Tesla, okay, or SpaceX. SpaceX has started a program called as Starlink. How many satellites are there in that? 100 plus satellites. It's a very big hub of satellites which are placed in the low Earth orbit to provide unprecedented communication signals or internet even in the remote areas. So that's why what happens in the low Earth orbit, my friends? In low Earth orbit, the satellite revolves at highest speed. If you are moving at the highest speed, can you observe or can you see what is happening on the Earth clearly? No, we cannot. So that's why we are not using the low Earth orbit for Earth observation. We are basically using it for remote sensing, and we can also use it for communication purpose when we have large number of satellites, because these satellites are moving at the faster rate, right? You need more number of satellites to cover more area in the faster rate. So that's what is your low Earth orbit. Generally ranges from 200 kilometers to 2000 kilometers from the surface above the Earth. And in this orbit itself, you will have our International Space Station, which is located at 400 kilometers above the surface of the Earth. This is very important point, my friend. Remember that our International Space Station is located in which orbit, my friend? It is located in the low Earth orbit. This is what I have wanted to tell you, that in low Earth orbit, the object has to revolve at a higher speed in order to escape from the Earth's gravitational pull. Okay. Now, as I said to you, what are the advantages of low Earth orbit? Low Earth orbits have advantages. LEO orbit have basic advantages like it can be used for experimental purposes. As low Earth orbits are very near to us, from the surface of the Earth it is basically 200 to 2000. Imagine I can easily go and come, right? For such a low height, I can easily go in a rocket, stay there, conduct some experiments and come back to the Earth. So this is one of the basic advantage, that's why we have placed International Space Station at 400 kilometers height. Now don't you think our scientists recently, Sunita Williams has also gone to the space, conducted latest experiments and came back. So this will help us to undergo various experiments. But the disadvantage is this, any satellite which is placed in this orbit will move at a higher speed, very speed. At this speed, do you even imagine that it can observe something on the Earth, or it can provide proper communication to any one single point? Say this is our Earth, say this is our low Earth orbit, I have placed the satellite here. Can it provide, at least provide communication signals to this much area on the Earth? Because it is moving very fast. Before it gives you any signal here, it will be here. So at such higher speed, one satellite cannot do anything for your communication purposes. So that's why we place lot number of satellites in this orbit so that it can provide proper communication to a one particular area. Say if this has moved, this satellite will give you the communication in that area. So large number of satellites are needed in order to provide you communication. This is biggest disadvantage of the objects in the low Earth orbit, and they have high risk of being pulled back to the Earth because of it gravitational pull, even because of a small failure. So this is one of the advantage and disadvantage of the low Earth orbit. Next very important orbit is polar orbit. My friends, polar orbit is also a type of low Earth orbit. Basically this orbit is called as polar orbit because it moves from pole to pole of the Earth, North Pole and the South Pole. It moves from pole to pole of the Earth. It is not always necessary. The polar orbit should always go from the pole to pole. It can also be inclined to the pole to pole by 20 to 30 degrees. This polar orbit can also be inclined 20 to 30 degrees from the poles like this. This angle, the angle between these two could be 20 degrees to 30 degrees. Angular difference could be possible in the polar orbit. These polar orbits are basically utilized to provide communications to high altitude regions and communications to remote regions of the earth. They provide communication signals. Communication, they are also used for spying purposes. They are also used for earth observatory in remote areas. Earth observatory purposes also. These are the three advantages of polar orbits. Basically, spying is a major advantage of the polar orbit. Next is sun synchronous orbit. My friends, sun synchronous orbit is this satellite will always be present at particular point when sun is available. Okay, whenever sun comes to India, this satellite will also comes to India, right? If you have seen a movie which is based on our India's Pokhran mission, okay, there is a movie, John Abraham has acted in that movie. If you have seen that Pokhran mission, you will see some satellites which are placed in the space by USA will always be coming to the site of Pokhran to observe whether India is conducting another nuclear test or not. You will see all the actors in that movie will be trying to remove all their traces. They always work in the night time because at morning times only that satellite is coming to that area. Such type of satellite which is coming into the morning and at that particular point which is in sync with the sun, When sun is here, this satellite will be here. When sun is there, that satellite will be there. So when it is in sync with the sun, such type of orbits are called as sun synchronous orbit. These type of sun synchronous orbits basically help you to observe the earth clearly, okay, taking remote sensing, earth observation for predicting the climate, and they also help you to understand the topography, remote sensing and spying purposes also. That type of satellite is called as what? Sun synchronous orbit. There is also another orbit called as semi-sun synchronous orbit. Basically, middle earth orbits, MEOs, or semi-sun synchronous orbit. Semi-sun synchronous means it takes 12 hours for this type of orbit. Any satellite which is placed in this semi-sun synchronous orbit, say this is Earth, this is semi-sun synchronous orbit. For any satellite which is placed in semi-sun synchronous orbit, it will take 12 hours to complete one revolution. 12 hours to complete one revolution. 12 hours to complete one particular revolution, that is called as semi-sun synchronous orbit. Next is elliptical orbits. In high elliptical orbit, my friends, you will have two types, high elliptical orbits and Molniya orbits. This is basically Russian spying orbit. Molniya orbit is a Russian spying orbit. Now, what is the advantage of this high elliptical orbit? What happens in high elliptical orbit is, my friend, whenever you place a satellite in this high elliptical orbit, whenever it comes nearer to the earth, it moves very fast as a swift, it moves very fast. Whenever it goes to the farthest point, it moves very slowly, very slowly. Now, what does this do? Whenever this satellite is very far, this slow movement will make this satellite to cover a larger region in the earth on the higher eccentric point. Whereas this shorter speed or the most speeding part does not allow you to observe at this point. So, these basically high elliptical orbits are used for earth observation. What they are used for? Earth observation. What happens here? Whenever satellite comes to the farthest point, it will cover larger area. Whenever it comes to the nearest point, it cannot observe anything clearly because it is moving very fast. So, that is why we place multiple satellites to cover the entire earth so that you can have a clear view of the earth. So, multiple satellites are placed in multiple elliptical orbits in order to cover the complete earth. You see, now the earth is covered here, earth is covered here, earth is also covered here. So, entire earth could be covered by placing 4 to 5 satellites or more satellites in high elliptical orbits. Okay. So, this is what I tried to explain you. I already said you what is a geosynchronous and geostationary. You can just go through these points. These are all basic. As I said you, this is geostationary, which is parallel to the equator of the earth, geosynchronous, which is inclined to the equator of the earth. They both are available at a height of 36,000 kilometers from the surface of the earth. This is another table which I always try to provide you, which you can always study. Next, middle earth orbit, my friends. Middle earth orbit are not generally chosen for any type of satellites to be placed in them, because middle earth orbit is present in a radiation belt or magnetic field based belt that is called as Van Allen radiation belt. You can see these magnetic lines. These are basically going to affect any particle or any object which you are going to place in the middle earth orbit. Because of the presence of these Van Allen radiation belts or magnetic field belts, any satellite which is placed in the middle earth orbit will get disrupted. These radiations will go and hit that satellite, and the satellite could damage, and the life of the satellite will be reduced eventually. But still we use this middle earth orbit because, my friend, they provide you good communication and they provide you good remote sensing capabilities. The GPS of USA, the global positioning system of USA, the Galileo of Europe, the Galileo of Europe, the GPS of USA, these two are basically navigation system. What are they? They provide you navigation. Car navigation you have seen, right? GPS based car navigation, you have your Google Maps, right? These two services, Galileo which provides that Google Map services in Europe and GPS which provides same services in USA, all the satellites of GPS and Galileo are placed in this middle earth orbit because they provide you better navigation systems. They are used for what? Navigation purposes. Middle earth orbit, where tomorrow one question will be asked, where is GPS placed or in which type of orbit is GPS system placed into? The GPS system is placed into which type of orbits, my friend? Middle earth orbit. As I already said you, semi-sun synchronous, which take 12 hours to complete one complete revolution around its orbit. A middle earth orbit is basically such type of orbit. I already said you Molniya orbit, because when I was teaching you high elliptical orbit, Molniya orbit is also a type of high elliptical orbit which is basically used for spying and providing communication to inaccessible regions. This is also used for communication in extreme north, the Siberian regions of the earth, extreme north, and they are also used for spy purposes, and earth observatory also. Observatory and resource monitoring also they can be used, because though it may not cover much area when it is at the nearest point, at the farthest point it can cover larger part of the earth. The only disadvantage is we need to place multiple satellites in multiple elliptical orbits to cover entire earth. To cover entire earth, what should happen? In multiple elliptical orbits we have to place multiple satellites. Hope you understood this concept of your orbits. You can just pause and read all of them. I am trying to explain you everything because this is a rapid revision. Be fast. Next is parking orbit. My friends, not always we can place a satellite directly into an orbit of 36,000 kilometers. There is no capability or no such powerful rocket which can directly take a satellite and put at 36,000 kilometers high. So that's why what we do is, initially we put this satellite into a low earth orbit. From there we do various maneuvers and eventually we take that into the desired orbit. I will show you the figure, you will understand how a parking orbit works. Now what we do is, initially we launch a satellite from the earth and we place in the nearest orbit like this. Say we have placed it in the nearest orbit. From here we will do various maneuvers and we will make the satellite to change its orbits, and eventually we will put that satellite in our desired location. This is called as maneuvering. Whenever it goes to this point, we will on the rockets which are attached to the satellite, and that rocket will push it into the next orbit. Again when it goes to the same point, it will again be pushed. These are called as maneuvering. This type of maneuvering is known as geosynchronous transfer orbit. Okay, Basically, there are few orbits in the space which are considered as transfer orbit, where you do all this maneuvering. Okay, hope you understand this. So, in these all orbits, what you are going to place? It could be a space station, it could be a satellite basically. Now, because the orbits are always limited and human activity into the space is booming, there are a lot of satellites in the space which are already dead and of no use. Most of these satellites which are dead or no use, they come back and fall to the earth. When they are coming into the earth, they are burnt by the atmosphere and they only fall partially. But these satellites, when they remain in those orbits, but these satellites which are dead or which are of no use remain in their orbit, they pose threat to the other satellites, because when it is moving in the space, it can go and hit the other satellites. When this other satellite is being hit, it creates a chain reaction hitting all other satellites, and this is mostly probable in the low Earth orbit. This type of chain reaction in which one satellite going and hitting the other, which creates lot of smaller pieces, and all the smaller pieces going and hitting all other satellites, which destroys entire communication system, is called as Kessler's syndrome. What is this, my friend? Kessler syndrome. Let me tell you what is this Kessler syndrome once again. Say this is our Earth, this is our orbit, say this is low Earth orbit. I will take low Earth orbit because in low Earth orbit there are most number of satellites. Now what happens, say there is a satellite here which is dead, but there are so many satellites, other satellites in this orbit. This is a very busy orbit, right? Now when this dead or uncontrollable satellite goes and hit this satellite, it went fast and boom. What happened? This satellite breaks and creates small tiny particles which could go and damage all other satellites. This satellite will get damaged and again it breaks. This causes breakage in this. This chain reaction which causes breakage in all the satellites in this orbit. This type of chain reaction is called as what? Kessler's syndrome. This is very important. One point you have to note, what is Kessler's syndrome? A chain reaction in which all the satellites in the given orbit are damaged because of one initial collision which causes most number of tiny particles, which creates a chain reaction. The last but not least orbit that you are going to learn is a Lagrange point. What is a Lagrange point? This you might have seen while you were learning or while you were looking at the news with respect to the Aditya L1 mission. What is L1 in this Aditya L1 mission? L1 stands for Lagrange point 1. When you see, my friends, between any two celestial objects in the space, there are few points where the gravitational pull of these two planets or these two celestial objects is ruled out. For example, say this is Sun, say this is your Sun and this is our Earth, and this is our Earth. Okay. Between Earth and Sun, there are few points where you place a satellite, it neither gets attracted to the Earth nor it gets attracted to the Sun. The gravitational pull of these two satellites or these two planetary objects get negated, and any object placed at these points will be stable and do not need to use much of energy to make it balanced. Such points in the space are called as Lagrange points. Between the Sun and the Earth, there are 5 such Lagrange points. Lagrange point 1 is between the Sun and the Earth. Lagrange point 2 is beyond the Earth. Lagrange point 3 is beyond the Sun. You can see point 3 is beyond the Sun. Point 2 is beyond the Earth. Point 1 is between the Sun and the Earth. Point 4 and 5 are at an inclination to the Sun and the Earth. Now you look at this diagram very carefully. Now see, my friends, what do you place in this Lagrange point 2? What is the use of these Lagrange points? My friends, in Lagrange point 2, what do we place is, we place satellites or telescopes which are used for observing the deep space. Now see, if I am placing a telescope here, is there any obstruction for this telescope? I have placed a telescope here. What happens? Earth always comes in between my telescope and the universe outside. So that's why I never place a telescope in Lagrange point 1. I would place a telescope in Lagrange point 2 because it gives me a clear vision of the whole universe. Whereas at Lagrange point 1, I will place such satellites which are used for observing the sun, because between sun and the earth there is no obstruction. I will always get a clear view. You might ask me, sir, why shouldn't I place a satellite in Lagrange point 3 to observe the sun? Here too nothing is there. You can place there also, but it is very hard for us to place a satellite there, and also for communication signals to come this far is very difficult, and the sun's radiation could disrupt all these communication signals. That's why we have placed Aditya L1 at Lagrange point 1. So what are Lagrange points? Lagrange points are those points between two celestial objects where the gravitational pull of these two celestial objects is cancelled out, and any object which is placed in this Lagrange point appears to be stable and do not need any energy to be consumed, so that it is protecting itself from being pulled to the either of these celestial objects. You have seen that any satellite which is placed around the earth, it has to continuously move, right, in order to protect itself from being pulled. That is what I said, centrifugal and centripetal forces. So hope you have understood. How many Lagrange points will be existing between any two planetary objects or celestial objects? 5. 1, 2, 3, 4 and 5 in the same way. Okay. So these are your orbits, my friends. Hope you have understood all of your orbits. These are few generic questions which might help you to understand what type of question can I make from an orbit. Look at this. A geostationary satellite is approximately at a height of 10,000 kilometers. What did I say? Geostationary or geosynchronous orbits are at a height of 36,000 kilometers. So this statement is absolutely wrong. FM transmission of music is of very good quality because the atmospheric man-made noises, which are generally frequency variations, can do little harm. So both the statements are basically wrong, my friends. So this is one type of question. This is another type of question which asked in previous years in different exams. Satellite used for telecommunication relay in geostationary orbit. I said you, basically communication satellites are placed in geostationary orbits. Now what is the specialty of this orbit, geostationary orbit? The orbit is geosynchronous. Yes, it is in sync with the earth. This orbit is circular. Yes, geostationary orbit is circular. I said you, it is parallel to the equator at 36,000 kilometer high. This orbit lies in the plane of earth equator. Yes, but the height is not this. This is not 22,000 kilometer but 36,000 kilometer. So your answer should be 1, 2 and 3 only. That is option A. Such type of questions will be asked in your exam. So be ready with the knowledge. Now let's start our genesis of ISRO. So now we shall start with the ISRO genesis. Why ISRO genesis is important from the exam point of view? Because we are writing an exam of UPSC CSC. So that's why this is an organization which is in our country. So before knowing what other country organizations like NASA, JAXA, Roscosmos do, or when did they evolve, you have to understand how did our space program has evolved. And the major, so today you are seeing private players coming into the space sector, the major contributor or major front runner till today also in India with respect to space segment is ISRO. That's why knowing the genesis of ISRO is very important. You can see the genesis of ISRO can be traced back to the efforts of Dr. Vikram Sarabhai. Dr. Vikram Sarabhai has seen that during the Tokyo Olympics of 1960, what happened? The US was able to live telecast all the events happening in the Japan, that is in Tokyo, directly to Washington DC. You have seen directly across the Pacific Ocean, we were able to broad telecast all the events happening at the Tokyo Olympics in USA. When Vikram Sarabhai have seen such a wonderful feat, he has seen that space technology could help in improving the livelihoods of all the people of India. So immediately, because of his efforts, they started a new organization called ISRO. Before ISRO, it started as an INCOSPAR. Okay, what is that? It started as INCOSPAR. Okay, Indian National Committee for Space Research. What is this INCOSPAR? Indian National Committee for Space Research. ISRO initially started as INCOSPAR. Okay, it later it turned into ISRO in the year 1969 in the month of August. Later, the government, when it understood the importance of this organization ISRO, it started two new organizations. One of it is Department of Space. Now, ISRO was shifted to the Department of Space. Earlier, this INCOSPAR along with ISRO, with INCOSPAR which was later converted into ISRO, was under Department of Atomic Energy. Now, this Department of Space was started in the year 1972, and Department of Space finally became an implementation agency for all the space related activities in India. So, these are the few important points you have to remember. Number one, ISRO, the name ISRO itself, the Indian Space Research Organization, formed in the year 1969. Its precursor was INCOSPAR, Indian National Committee for Space Research, and ISRO is converted, or ISRO works under Department of Space. Department of Space itself was formed in the year 1972. So I have said you the story that how the Tokyo Olympics were live telecasted by using Syncom satellite. That was observed by Dr. Vikram Sarabhai. Vikram Sarabhai, then he was the director of Physical Research Laboratory of India in Ahmedabad. He thought such a wonderful thing could help India to grow economically in all the ways. He thought, why can't I use this satellite technology for making children of our country to study via television network? Why can't I make training of the teachers, training of various other professionals by using these telecommunication networks? So, based on this idea, in the year 1975 and 76, there happened an experiment called as SITE experiment. What is this? SITE, satellite communication based television experiment, my friends. Okay, this SITE experiment, what did this SITE experiment did was, it utilized this satellite communication technology to send data with respect to the Kisan Bharat, that is how to use farm implements, what are the best practices in farm. And we also try to use this technology to teach our children by using television, to train teachers by using television. And this SITE experiment of 1975-76, which was conducted by ISRO, is considered to be world's largest sociological experiment. World's largest sociological experiment. Around 2 lakh people were involved in this experiment. You can see each and every point in the slide I tried to highlight for you. That is, when was INCOSPAR formed, how did INCOSPAR turn into your ISRO in 1969, INCOSPAR formed in 1962 under Department of Atomic Energy. Later this ISRO, which was formed in 1969, was taken and given to the Department of Space, that is in the year 1972, that is September. Okay. So, as I said you, we were able to conduct experiments such as SITE. Initially we have started a TV channel called Krishi Darshan or Kisan Darshan, where you were able to help farmers to develop among themselves by sending them clarity information on weather forecasting, and we have also sent them information how to do best practices of farming. I said you there we did a SITE experiment, that is satellite instruction television experiment, which happened in 1975-76. It was the world's largest sociological experiment. These all what we were doing is, we were trying to showcase how space technology could enhance our living capabilities, how we can change our lives or lives of people of India. With such a huge population and poverty, space technology was the only solution to make change in the lives of the people. Later, every other projects were coming out. One such project on the basis of SITE was STEP, that is Satellite Telecommunication Experiment. We utilized this German technology or German based satellite system to do this experiment called as STEP. In STEP also what we did, we used telegraph, that is telephone technology and television technology, to disseminate the information, to disseminate the knowledge. So these were the experiments. SITE was one of the experiment. The other experiment was STEP, and later these experiments were converted to KHEDA Communications Project. It was an experimental project in Gujarat in collaboration with UNESCO, which helped to develop communication systems in that region of KHEDA, where we were able to help the farmers to gain the knowledge. Now, during all this period when these experiments were also happening, India was also planning to have its own satellites and its own launch vehicles in parallel. But for such a new country like India and with such a limited budget, we weren't able to expect to start our own launch vehicles. So instead of waiting to design our own launch vehicle and to design our own satellites, we always had a good communication with our friendly countries like Russia, US and all others, and by using Russian satellite launch vehicle, India has launched its first satellite, which is called as Aryabhatta. Okay, what was the India's first satellite, my friends? Aryabhatta. So later, after this launch, after a lot of experiments, we were able to develop India's first satellite launch vehicle, that is called as SLV. SLV was very little technology or a rudimentary technology. With SLV, we were able to only place a 40 kg satellite into the low Earth orbit. This happened in 1980. Based upon the knowledge from various launches of SLV, these are all experimental launches, we were able to develop another launch vehicle called as Augmented Satellite Launch Vehicle. Based upon the inputs from the augmented launch vehicles, India developed its workhorse, that is called as Polar Satellite Launch Vehicle PSLV in the years of 1990s. Around 1999, this PSLV was fully inducted and it was making successful launches. Based upon the knowledge of PSLV, the next launch vehicle we developed was Geosynchronous Satellite Launch Vehicle, that is GSLV. Okay, what are these GSLV, PSLV, SSLV, that is satellite launch, small satellite launch vehicle, we will be discussing in the next session, that is upon the launch vehicles. So this was your genesis of ISRO. That is how the ISRO formed. When did it form? Only few points are necessary, not every other point is needed. Point number one, it started as INCOSPAR in 1962. It changed its terminology into ISRO in 1969. The initial experiments of this INCOSPAR were conducted at Tumba Equatorial Research Center, where it was conducted as Tumba Equatorial Research Center. Tumba is basically a place in Kerala. Okay, at this Tumba, in an old church, scientists were able to conduct the experiments. The first figure itself, I was trying to show you the church where the ISRO initially started as INCOSPAR. This was the church. Okay, this was the church, the Mary Magdalene Church in Thiruvananthapuram. Here is where your ISRO has started, in this small church. So here the scientists used to conduct experiments. There are two equators to the Earth. How many equators are there to the Earth? One is geographical equator, another is magnetic equator. What are the two equators the Earth has? Geographic equator and the magnetic equator. I will show you what is a, if this is your Earth, this is geographical north and geographical south, this will be your geographical equator. But your north and south magnetic poles are inclined like this. This is north pole, this is north magnetic pole and south magnetic pole. Then your magnetic equator will be like this. This is geographic equator, this is magnetic equator. Now this Tumba equatorial region is basically at a place which is located on magnetic equator of the Earth. And magnetic equator of the Earth helps you to launch the satellites much easier and much better. So initially our experiment started at Tumba, and later in 1969 we formed ISRO. The headquarter of ISRO is in Bengaluru. Where is the headquarter of ISRO? Bengaluru. In August 1969, we formed ISRO. Later, ISRO was placed under the Department of Space, which was created in the year 1972. The chairman of ISRO will also act as the secretary to the Department of Space. Remember this point, the chairman of ISRO is also the secretary for the Department of Space. A small question, who is the present chairman of ISRO? Please comment in the comment section. So this was your genesis. Later on, remember the SITE program, the world's largest sociological experiment. Basically, we were able to train teachers by using this SITE experiment. By using television communication, we are able to train the teachers. Happened in the year 75, 76. SITE led to other such similar type of experiments. Next, we were also able to launch Aryabhatta. We did not rely on our own satellite launch vehicles. Initially, we started satellite launch vehicles in the year 1980 by SLV. Later 1980, later 1987, we were able to launch augmented satellite launch vehicle, which led to the development of workhorse of ISRO, that is PSLV. Happened to be in the years of 1993 to 1998. We were able to finally make it perfect. Next, we developed our geosynchronous satellite launch vehicle around 2007-2008. Now we are on our path to develop a new generation launch vehicle. Today, Indian startup companies are also developing their own launch vehicles. For example, Agnikul Cosmos is the world's first 3D printed rocket launch vehicle, my friends. World's first 3D printed rocket. We have seen Mission Prarambh. Under Mission Prarambh, we have seen an Hyderabad based startup company, please comment, that is Skyroot Aerospace, was able to develop its own launch vehicle. It is India's first private launch vehicle, that is under Mission Prarambh by whom, my friends? Skyroot Aerospace. So this is the vision of the ISRO, to harness space technology for the national development while pursuing space science research and planetary exploration. So this is the organizational chart. Basically, Department of Space directly falls under the Prime Minister's office. Under whose organizational control does Department of Space works, my friend? If someone asks you tomorrow, that is works under the Prime Minister's office. Under Department of Space, you can see there is an organization called India Space, Indian Space Authorization Center. You have New Space India Limited, Antrix. These are basically commercial arms of ISRO. Under Department of Space, ISRO has various laboratories. These are all the laboratories of ISRO. Various center, UR Rao Space Center, okay, UR Rao Space Center and National Remote Sensing Center. These are all the different laboratories which are under the ISRO. Let's see few of the laboratories if you can remember. Okay. Now at present, my friend, ISRO has 3 launch pads. These are one important points I would like to say. How many launch pads ISRO has? Presently it has 2 and it is about to develop one more. So overall we can say 3 launch pads. What is this launch pad? In order to launch a rocket into the space, you need an area designated to launch that rocket. And that area designated to launch a particular rocket is called as launch pad. Not every launch pad can handle the amount of heat and pressure that a rocket inserts on it. So initially of these 2, one is for respect to PSLV launches, another is for GSLV launches. Now we also need another for small satellite launch vehicles and also for new generation launch vehicle. We are trying to build a new launch pad at which point, my friend? Sriharikota. That is Satish Dhawan Space Center. Sriharikota, Satish Dhawan Space Center. Okay. And India has also planned to build a new launch pad at a place called Kulashekharapatnam to avoid dogleg maneuvering. That is, for example, my friend, this is our country India, this is Sri Lanka, this is where Andhra Pradesh is present. Whenever India launches, they launches to the south. Like this the launch goes. So what is happening is, in order to avoid our launch to go on to the Sri Lanka, what if tomorrow the launch fails? The rocket might come and fall on Sri Lanka, right? In order to avoid that, we were doing this maneuvering, this curved maneuvering, and this curved maneuvering was costing lot of fuel to the ISRO. Now what is government planning is, what ISRO is planning is to build a launch pad here so that we can avoid this dogleg maneuvering and save lot of fuel, which could even make our launches easier and also utilize this wasted fuel which was used in maneuvering. This type of maneuvering is called as dogleg maneuvering, which is used in this process could be used to uplift much higher into the space. So remember this, at present we are having only 2 launch pads, my friend. Those both are available in the Satish Dhawan Space Center, Sriharikota. We are planning for the third and another one at Kulashekharapatnam, which is in Tamil Nadu. So remember that. So my friends, let's learn about the various centers of ISRO. Let's first center that we are going to learn is Sriharikota, that is Satish Dhawan Space Center. My friend, Sriharikota or Satish Dhawan Space Center is considered to be the spaceport of India. It is what, my friend? This is the spaceport of India. At present, this spaceport of India has 2 launch pads. One is used for launching PSLV satellite launch vehicle, another is used for launching GSLV satellite launch vehicles. There is a proposal to construct the third port which could be used for launching the small satellite launch vehicles and the next generation launch vehicle. At present, small satellite launch vehicles are used or launched by using the launch pad which is already under PSLV usage. Now, the other thing that you have to note down with respect to the Satish Dhawan Space Center, that is in Sriharikota, Andhra Pradesh, is this center also develops the solid fuel boosters of our country. It develops the solid propellant boosters. It also is equipped with this all development programs which are related to the solid subsystems, and it is the space port of India, that is launch port of India. Next is National Remote Sensing Center. National Remote Sensing Center is available in Hyderabad, Telangana. This National Remote Sensing Center will provide you remote sensing data, accurate maps which are used during emergency time. Even during the time of COVID, this National Remote Sensing Center has provided its various services. Next, Liquid Propulsion System Center. There are 2 liquid propulsion system centers at present. One is at Thiruvananthapuram and another is in Bengaluru. What does this liquid propulsion system does? The name itself says they develop the liquid propulsion systems of our Indian rockets or Indian launch vehicles. Next is master control facility. The name itself says master control facilities. Whatever satellite you are going to place in the space, okay, those are all controlled, the maneuvering, their location in the space, their orbit in the space, the operations that satellite does, they're all controlled by this master control facility. There are 2 master control facilities, one is in Hassan and another is in Bhopal, Madhya Pradesh. Hassan is in Karnataka. Very, very important, because this master control facility will help you to rise the different orbits. As I said you, from geosynchronous transfer orbit we rise the satellites to higher orbits, right? That maneuvering is done by this master control facility. Where does this master control facility happens? One is in Hassan, Karnataka, another is in Madhya Pradesh. The next center is ISRO Inertial Systems Unit. Very, very important. ISRO Inertial System Unit is present in Thiruvananthapuram, Kerala. What does this inertial system do? They develop gyroscope, inertial navigation systems of rockets. Okay, inertial navigation systems of rockets are developed by this system. Basically, they develop gyroscopes, that is the instruments which keep the rocket to be stable even when it is in the air. Next, UR Rao Satellite Center. This is India's premium satellite development center. Very, very important center, my friend. UR Rao Satellite Center. It is available in Bengaluru. What does it do? They develop satellites for navigation purpose, for meteorological purpose, earth observation purpose, communication purpose, remote sensing purpose and all other purpose. Laboratory for electro-optic systems. They develop, this is in Bangalore, my friend, they develop the optics of your space observation. That is your lens, all those sensors, all are developed by this. Indian Institute of Remote Sensing, IRRS, very another important institution. This is available in Dehradun. This collects geoinformations and geoinformatics related to remote sensing, my friends. So just remember, this is not too much important. Next, other is Vikram Space Station, another important space station that is in Thiruvananthapuram. This is a leading center to develop and design India's launch vehicle. Please note down this important organization, that is Vikram Sarabhai Space Station. What does Vikram Sarabhai Space Station do? It is the space center or the research center where India's launch vehicles are designed and developed. The complete design and development of launch vehicles, its structure, its propulsion, its physics, all are done by this Vikram Sarabhai Space Center. ISRO Propulsion Complex, here is where you do propulsion experiments, there where you test your solid boosters, where you test your liquid propulsion engines, whether they are working to the optimum level or not. All they are done in the ISRO Propulsion Center. It is located in Mahendragiri. Where it is located, my friend? It is located in Mahendragiri. Next, the Development and Education Communication Unit, that is utilization of space technology for education and all other extra applications. This is located in Ahmedabad. For social applications or societal applications, this center works. Next, ISRO Telemetry Tracking Command Network. What does this ISRO Telemetry Tracking Command Network does? It provides support to the satellites. Where does the satellite is, how it is working, all those diagnosis will be done, and it will help all the satellite launch vehicle to place that particular satellite in a particular orbit. Where is this ISRO Telemetry Tracking and Command Network is present? It is present in Bengaluru. Okay, so these were the important institutions of ISRO. Now we will come to the major part of our ISRO, that is launch vehicles which are developed by ISRO. Each and every launch vehicle is a very important point. Now why do we need launch vehicles? My friends, every celestial object has a gravitational pull in it. And in order to escape from the gravitational pull of that celestial object, we have to move with a higher speed. We have to move with what? Higher speed. Now in order to escape from the gravitational pull of the earth, I have to go to the higher speed so that I can make an object to go into the space. And the speed that is needed to escape from the gravitational pull of the earth and stay in the space itself. What I am saying you, my friends, imagine this is earth and I am pulling this pen very hard, and in order to escape from my pull and go into the space and remain in this particular space, you need certain force or certain velocity to do all this thing. And that velocity which is needed for an object so that it can escape from the earth's gravitational pull is called as escape velocity. What is escape velocity, my friend? The velocity at which or the speed at which an object should move from the surface of the earth so that it is not pulled back by the gravitational pull of the earth is called as escape velocity. And the escape velocity of the earth is around 11 kilometer per second. Almost what, my friend? 11 kilometer per second is, in 1 second I have to move 11 kilometers. That is the escape velocity of the earth. Very important. And the formula for the escape velocity is given by escape velocity is equal to square root of universal gravitational constant. What is G here? Universal gravitational constant 2g into, where m is the mass of the earth and r is the radius of the earth. Here you can put m and r variably depending upon what planet you are going to choose. If you are going to take moon, this m will be the mass of the moon and r will be the what, my friends? R will be the radius of the moon. So this escape velocity concept is very important to understand the launch vehicles. Now to achieve this escape velocity of 11 kilometers per second, you need certain vehicle, and that vehicle or that force is exerted by our launch vehicles. In order to escape from the earth gravitational pull and to stay in the space, we developed various launch vehicles. First launch vehicle that India has developed is called as Satellite Launch Vehicle, SLV. SLV was developed in the year 1980. It was very little capacity launch vehicle. It was only able to place a 40 kg satellite into the low earth orbit. What do you think this 40 kg is? Nothing. As big as a 10th class child. Nothing you can do with these small satellites. So India thought, let's develop much more sophisticated technology to put much further satellites. Around 4 launches were happened with the small satellite launch, that is satellite launch vehicle. Under this we have done Rohini experiments. After Rohini experiment successful, we started to develop another satellite launch vehicle called augmented satellite launch vehicle. The major aim of this augmented satellite launch vehicle was to develop a new satellite launch vehicle which has higher capability and etc. In order to develop that new launch vehicle, we did lot of experiments in this augmented satellite launch vehicle. We kept on adding new technologies, we did experiments on this, and finally we got an output that was named as PSLV, Polar Satellite Launch Vehicle. The next launch vehicle was augmented satellite launch vehicle after the satellite launch vehicle SLV. This augmented satellite launch vehicle was basically having 3 times the capability of SLV, which was able to place around 150 kg of satellite in the low Earth orbit. And this is how the SLV would look like. Now the next, the specifications of these two is not much necessary, but the next important satellite launch vehicle we have to see are sounding rockets. What are these sounding rockets? Sounding rocket is basically a type of rocket which are used for probing the upper atmospheric layers. In geography, you might have seen your upper atmospheric layers, ionosphere, exosphere, thermosphere, all these are your upper atmospheric layers, right? In order to probe, in order to study, probing is studying, study this upper atmospheric layers, what is happening in that layers, what type of forces are there in that layer, how does the matter behave in that particular higher levels. We have developed certain rockets called as sounding rockets. Mostly Thumba Equatorial Research Center, which I have said you, uses these sounding rockets, and various instruments are attached to these sounding rockets. They are sent into the space near low Earth orbit, and various experiments are conducted on these instruments, and these instruments will be utilized in enhancing the real launch vehicles of our country, that is PSLV and GSLV. Hope you understood. We conduct various experiments by using sounding rockets. Okay. From where do we launch our sounding rockets? Thumba Equatorial Research Center. Thumba Equatorial Research Center is located at what? The magnetic equator of the Earth. So sounding rockets are basically two-stage rockets, my friends. They are basically solid fuel. Now, the workhorse of ISRO, that is PSLV, Polar Satellite Launch Vehicle. My friend, PSLV is a 4-stage satellite launch vehicle. First stage is solid, second stage is liquid, third stage is solid, and fourth stage is liquid. Solid, liquid and solid liquid stage of launch vehicle is PSLV. What is the capacity of PSLV is very, very important. My friends, PSLV is the third generation launch vehicle of India. It is called as workhorse of ISRO because of its low level of failure, and it is the first launch vehicle of ISRO to have liquid propulsion stages. Initially, the SLV or ASLV both were only solid propellant, that is they use only solid fuel to get into the space, whereas PSLV became first satellite launch vehicle of India to have liquid stages, that is stages which use liquid fuel. How many stages are there? 1, 2, 3, 4 stages. First stage solid, liquid, solid and liquid. Okay. Always remember, my friend, for all the satellite launch vehicles, the initial stage will always be used solid fuel. The initial stages will always use which type of fuel, my friend? Almost for all the satellite launch vehicles, solid fuel, because solid fuel will give you higher initial thrust to launch the vehicle. Now, when you are looking this satellite launch vehicle, this PSLV was used to launch famous missions like Chandrayaan 1 mission and also your Mangalyaan mission, that is Mars Orbital mission. These two missions were launched by using this satellite launch vehicle, that is PSLV. Now PSLV, if you see the technical specification, it can put a satellite of weight almost 1750 kilograms in a sun synchronous polar orbit, whereas it can put 1425 kg of satellite into the geosynchronous transfer orbit. Very, very important. Payloads are important, 1750 into the sun synchronous polar orbit and 1450 into the geosynchronous transfer orbit, GTO. It is not geosynchronous orbit but GTO. As I said you, PSLV has 4 stages. First stage is solid, second stage is liquid, third stage is again liquid, solid, and fourth stage is again liquid. Solid, liquid and solid, liquid. Solid, liquid, solid, liquid. Hope you can remember this one. Where does liquid engine develop, my friend? Liquid Propulsion Center. Where is Liquid Propulsion Center available? Liquid Propulsion Center is available in Bengaluru. We have seen just now. So that's very important. Okay, solid engine, my friend. In India, we have our own solid engines and our own liquid engines. I'll tell you one important point. Liquid engine, name of liquid engine for India is Vikas engine. Okay, remember this one point. The name of liquid engine of India is what, my friends? Vikas engine. Next, PSLV has different variants. One, PSLV core alone, PSLV XL. Here the differentiation happens is these are called as strap-on boosters. If a PSLV does not have a strap-on boosters, if PSLV does not have a strap-on boosters, it is called as PSLV core alone. But if it has these strap-on boosters, and each strap-on booster, these are called strap-on boosters, and if each strap-on booster has a capacity of 6 ton, that is it can lift a 6 ton weight. If each strap-on booster has a capacity of 6 ton, it will be called as PSLV G variant. Whereas if it has a capacity of 12 ton, if it has a capacity of 12 ton each, it will be called as PSLV XL variant. Remember, PSLV has 3 variants: PSLV G, PSLV XL, PSLV core alone. Core alone has no strap-on boosters. Where can you find the strap-on boosters, my friends? In the original figure you can see the strap-on boosters are available in the first stage of your launch. This is where you will see the strap-on boosters in the first stage of your launch. Now these strap-on boosters, if they are not available, that version of PSLV is called as PSLV core alone. If they are available, if it is of 6 ton capacity, it is called as PSLV G. If it is of 9 ton to 12 ton capacity, it is called as what, my friend? PSLV XL capacity. These are very, very important. Now PSLV has a unique capability that is called as payload fairing. The PSLV is the only satellite launch vehicle in India which can put multiple satellites in the multiple orbits. What is the payload fairing is called as? Payload fairing is capability of PSLV to put multiple satellites into multiple orbits. It can place one satellite in low Earth orbit, another satellite in geosynchronous transfer orbit. That capability of PSLV is called as payload fairing. What is payload fairing? PSLV, specialty of PSLV is it can put multiple satellites into multiple different orbits. That is one important point you have to remember with PSLV. The next important satellite launch vehicle of ISRO is GSLV. GSLV has two versions. GSLV stands for Geosynchronous Satellite Launch Vehicle. GSLV has two versions, GSLV Mark II and GSLV Mark III. GSLV Mark II is most unsuccessful one, whereas GSLV Mark III is the most powerful launch vehicle of ISRO. The coming missions of ISRO, that is manned mission, that is Gaganyaan mission, and the Chandrayaan 3 mission were conducted by using this GSLV Mark III launch vehicle because they have heavy lift capability and they can place launch or satellites which can be put in geosynchronous orbit, that is at a height of 36,000 kilometers. And this GSLV is basically a 3-stage launch vehicle with initial solid stage, second liquid stage and third cryogenic stage. GSLV is the only launch vehicle of ISRO which has cryogenic capability. Which has what, my friends? Cryogenic capability. Cryogenics is basically a science which deals with -degree Celsius temperatures. Okay. What is the first stage of GSLV, my friends? This GSLV Mark II vehicle, my friend. Okay, these are 4th generation launch vehicle. First phase you have solid, second phase you have liquid, in the third stage you have cryogenic phase. Okay, this is GSLV Mark III. This is called as fat boy of ISRO because it is very, very high capable rocket. This GSLV Mark III, or this is also called as launch vehicle Mark III, it was used in launching Chandrayaan 2 mission, though the mission was partially successful. Now let's see how does this rocket looks. It has a 2 solid strap-on boosters, a core liquid booster. This is 2 are solid boosters. This is a liquid booster and an upper cryogenic phase. Initially the design was different, GSLV Mark II. Later the design was changed. These 2 are solid strap-on boosters. This is a core liquid booster and this is a cryogenic phase, which is basically used for lifting heavy satellites. I will show you the payload capacity that it can take. This is the payload capacity. You see, whereas PSLV can put only 1400 kg or 1450 kg of satellite into the geosynchronous transfer orbit, but GSLV can put almost 4004 kg of satellite into the transfer orbit, geosynchronous transfer orbit. Whereas PSLV could place around 1750 into the low orbit, whereas GSLV could place around 8000 kg of satellite into the low Earth orbit. These two specifications are important. My friend, cryogenic engines basically use liquid hydrogen and liquid oxygen. What do we use in cryogenic engine, my friend? Liquid hydrogen and liquid oxygen. When these both liquid hydrogen and liquid oxygen are sent into the combustion chamber, they get reacted and they release huge amount of heat, and the byproduct of this liquid hydrogen and liquid oxygen will be water, but it initially gives you lot of heat. This heat is used for boosting. Okay, so this is how a cryogenic engine works. We use helium. Helium is basically an inert gas. We use the helium gas to pressure. There is no use of helium here. Helium is only used to push this oxygen, liquid oxygen and liquid hydrogen into the fuel chamber. Inside the fuel chamber, these two liquid oxygen, liquid hydrogen get reacted and they form higher amount of energy. You know, this liquid hydrogen and liquid oxygen what we are using are at negative degree Celsius. Almost liquid hydrogen is at minus 253 degrees and liquid oxygen is at minus 183 degrees Celsius. As we are dealing with negative degree Celsius fuels, this technology is called as cryogenic technology. India is the only country in the world which has developed its own cryogenic technology. Okay, it is one of the only. So USA and Russia has developed their own technology, but we have developed our own indigenous technology without borrowing anyone. Though we were able to take an old cryogenic engine from Russia, we did reverse engineering. After performing reverse engineering, we developed our own cryogenic India, and we did not buy it from any other country. Okay, these are the different missions that GSLV Mark III has done. In future, you are going to see this GSLV Mark III to conduct the Gaganyaan mission. So this shows you the different launch vehicles and their specifications and their picture. I would like you to pause and look at this picture once again. Now, the next generation launch vehicles of ISRO include reusable launch vehicle technology demonstration, RSLV TD. This is now named as Pushpak. Now you are seeing in the videos of YouTube where a SpaceX rocket will launch a satellite or a rocket into the space, and the booster will come back and get attached to the earth. This type of boosters, which can be used again and again, are called as reusable launch vehicles. And India has also developed its own reusable launch vehicle. The name of that reusable launch vehicle is what, my friend? The name of that reusable launch vehicle is Pushpak. Very, very important. And now when it comes to the space, one important term you have to remember is Kármán line. What is this Kármán line? Now there was a dispute among the scientists or among various companies saying that from where do this outer space start? Right? Now there was a person called Kármán. He was a pilot. Under his name, most of the people accept that the outer space starts at 100 kilometer from the surface of the earth, and the line which is available, an imaginary line which is available at this height of 100 kilometers, which is internationally recognized, is called as Kármán line. This is the point from where your outer space starts at. What is Kármán line? At what height this Kármán line is available? Kármán line is available at 100 kilometers from the above the surface of the earth. Okay, beyond this 100 kilometers, everything is considered to be what? Outer space. This is how reusable launch vehicle look like. This was a technology demonstration. This is the fuselage in which your person sits, a astronaut or a satellite sits. This is the booster. This is basically a solid booster which will lift off this payload and make it possible. My friend, this vehicle is an autonomous vehicle. It cannot fly by itself, but it can land autonomously. Autonomous navigation system and autonomous landing systems were recently tested under this vehicle. This vehicle today it is called as Pushpak. Okay. So last but not least, three major important engines you have to understand with respect to this space technology. One is turbo, ramjet and a scramjet. Turbo engines are engines which are used in aeroplanes. You see large aeroplanes, rotary wings, right? Those are turbo engines. In turbo engines, there are rotating blades. When we remove these rotating blades and make the design simple, that is called as ramjet engine. That is called as what, my friends? Ramjet engine. Okay, this is turbo engine, this is ramjet engine. The development of ramjet engine will lead to another engine called as scramjet engine. Scramjet engine is supersonic combustion ramjet engine. What does SC in scramjet engine stand for? Development of ramjet will lead to scramjet. SC stands for supersonic combustion. Supersonic combustion. Okay, supersonic combustion. What is the difference is this engines, both ramjet and scramjet engines, use the oxygen from the air to combust the fuel, and they can even burn the fuel at supersonic and supersonic speeds. It is not easy, my friend, when you are moving at such a high speed to take the oxygen from the atmosphere and to burn the fuel what we are using. And such technology is only possible by this scramjet and ramjet engines. What is the specialty of scram and ramjet? They do not carry an oxidizer. To burn any fuel, my friend, you need oxygen, you need oxidizer. In turbo engine, you are using oxidizers, large oxidizers you are using. But in ram and scramjet engine, you have removed that oxidizer from the vehicle. So imagine how light your flight will become. Without any oxidizer, using oxygen directly from the space, if you are able to burn the fuel, that type of technology is only possible by scram and ramjet engine. Ramjet engine has no moving parts and scramjet engine has much lesser moving parts than the ramjet engine. Scram means what? Supersonic combustion based ramjet engine. That is combustion which is possible at supersonic speeds. So we will meet and discuss more and more topics, my friends. So last, one important point, if you observe, most of the launches which are performed by using these launch vehicles happens to be towards east side of the continents. Why do we do launches to the east side of the continent? And most of the launch pads are available near to the equator. Why launch pads are available near to the equator is, whenever you are launching a vehicle from the equator, the Coriolis force of the earth will give an initial push to the launch vehicle. Okay, whenever a launch pad is available near the equator, the Coriolis force will give you an initial push. The rotation of the earth basically give you an initial push, which saves a lot of fuel. And if you are going to the east side, there is less land on the east side of the continents, which will cause lesser damage if the mission fails. We are now going to learn about the different types of satellite system that ISRO has developed over a period of time. When you want to divide these satellite systems, I would like to tell you there are two major important satellite systems. One is communication satellite system and another is Earth observatory satellite systems. While we were learning our orbits, I have already made you clear that communication satellite systems are majorly placed in the geosynchronous orbit or geostationary orbit. Yes, that is the orbit which is around 36,000 km from the surface of the earth. Those are the 2 points. Apart from that, we will also try to see what were the names of these communication satellite series or Earth observatory satellite series that India has developed. One must immediately understand that if you are going to listen a series called as INSAT series, Indian National Satellite Systems, or INSAT series of satellite systems are basically communication satellite systems that ISRO has launched over a period of time. As of today, the INSAT series has been replaced by the GSAT series. Initially, the INSAT series, that is Indian National Satellite System, was launched by the year 1983, and later on various INSAT missions were sent and a constellation of satellites were built in the geostationary and geosynchronous orbits so that they can provide us communication system. So remember, what is the series of satellites that India has sent in order to provide communication services to India? That is INSAT based satellites. Do you know that these INSAT-based satellites are very helpful for us in providing telephone communications, television services, broadcasting services, satellite news gathering, okay, weather forecasting and etc. Next is Earth observatory satellites. Most of the Earth observatory satellites are also placed in the geostationary, and they are also sometimes placed in the low Earth orbit in large number of constellations, so that we observe the Earth very clearly. Mostly these Earth observatory satellites are used in weather forecasting, meteorological services and etc. And India has its own Earth observatory satellite system. Those are Indian Resource Satellite Systems, IRS series, ResourceSat, Cartosat. These are all the different types of Earth observatory satellite series that ISRO has launched. Just remember, IRS is a series of satellites that ISRO has launched for Earth observatory. Apart from IRS, we are also having a series like Cartosat, ResourceSat, ReSat, OceanSat. OceanSat specially focuses on your ocean related services. Okay. These are the two basic types of satellites. They are also having wide range of applications. They look at different areas. You know, I would like to also provide you one important point. The satellites like Earth observatory satellites, they are also able to weather forecast. They can predict the incoming of any type of locust attacks. They are used for disaster management. They can be used in order to know the crop output, predict crop outputs. We can predict is the amount of plankton in the ocean is increasing or decreasing. We can also predict pollution levels in the ocean or in the predict pollution levels, visible pollution levels. Okay, we can predict the plankton growth, we can predict the plant growth, we can measure the amount of chlorophyll also. We can even measure amount of chlorophyll. We can also measure the amount of chlorophyll, that is the green substance that is present in the plants on the surface of the earth. All these can be predicted. All these can be predicted. Satellite technology is such a wide that by using proper lenses, proper spectrum, we can detect and we can predict almost anything and everything. So try to remember these points, that we can use it for disaster management, predict the locust attacks, predict epidemics. Okay, outbreak of epidemics can also be managed, predict pollution levels. We can also measure the amount of chlorophyll in the plants. All these could be useful for you to solve a question. Okay, let's go for the next. Next is IRNSS. Very important, my friend. IRNSS stands for Indian Regional Navigation Satellite Systems. Okay, these are basically navigation satellite systems, which is also called as NAVIC. IRNSS is also called as what, my friend? NAVIC. NAVIC stands for Navigation in Indian Constellation. IRNSS is a constellation of 7 satellites. 7 satellites. In 7 satellites, 3 are placed in geostationary, and whereas 4 are placed in geosynchronous. That is, 3 are placed in the orbit which is parallel to the equator, and 4 are placed in the geosynchronous orbit which are inclined to the equator at the same height of 36,000 km. As GPS is for USA, that is Global Positioning System Services, is a mapping services. We all have our Google Maps, right? It's a mapping services which is created by the USA. In the same line, we have also developed our own regional navigation system, so that we are having increased accuracy, and we are also having clear-cut vision of our borders to protect ourselves from the neighboring countries, to predict the security attacks or security threats happening across the border. We have developed our own regional navigation satellite system called IRNSS. My friends, across the world there are various regional navigation satellite systems. I would like to mention here them. Number 1, GPS is the global navigation system basically developed by USA. Okay, next Galileo. Galileo is the European based regional navigation system developed by European Space Agency. Okay, it's a European based, and you have Japanese navigation system that is called as quasi-zenith. Quasi-zenith. We have Chinese navigation system which is called as Baidio. Baido. Okay. Apart from that, we also have Russian navigation system. What is Russian navigation system? Please try to comment in the comment section. I gave you 4. Try to find what is the name of Russia's regional navigation satellite system. So IRNSS, being the India's regional navigation system, is completely developed by ISRO. Of these, there are 7 satellites. 4 are placed in the geosynchronous and 3 are placed in the geostationary. Do you know one important point here, my friend? This IRNSS does not just cover India. It covers the area beyond the borders of India up till 1500 kilometers. What is that, my friend? Imagine this is our country, our beautiful country. This is our country, imagine that. Our IRNSS goes beyond 1500 kilometers from the borders of India. That means it encompasses the countries of Sri Lanka, Bangladesh, Nepal, Bhutan and Pakistan, and even the parts of China which India has border with. So what is the use of this beyond 1500 capability is that we can clearly manage our borders by having the clear pictures of our border which are taken by the IRNSS. How many constellations of satellites are there in the IRNSS, my friend? There are 7 constellations in IRNSS. IRNSS provides 2 types of services. One are standard services, another are restricted services. As I said you, the military applications of IRNSS goes into the restricted services, whereas providing mapping, accurate mapping services, drone services, usage of data from the IRNSS for drone mapping, all these are the standard services which are meant for the general public. Try to note down these 2 points. Okay, as I said you, this goes beyond the range of our Indian border up till 1500 kilometers. Yes, in the orbits I have said you one important point, that Galileo, the regional navigation system of Europe, and the GPS, the navigation system of USA, these both are in which orbits, my friend? These both are in the middle earth orbits. These both are in the middle earth orbits. These are some important points. As I also said you, when you go to the geosynchronous or geostationary orbits, you need less number of satellites to observe the complete earth. So that's why only 7 satellites were enough for us to cover the entire India and the border beyond 1500 kilometers, whereas GPS has around 24 satellites in its constellation. Remember this point. My friends, when it comes to the accuracy with respect to GPS and NAVIC, that is Indian Regional Navigation System, I would like to mention you one important point here. That IRNSS, that is our NAVIC, has far more accuracy than the GPS. The accuracy is up to 5 meters, whereas for the GPS, the accuracy is just for 20 to 30 meters. So remember one point, that NAVIC provides higher accuracy than GPS. And one important point here, my friend, GPS only operates in the L band, whereas the NAVIC or IRNSS operates in both L and S bands. My friends, here L and S bands are basically the radio frequency bands. L and S bands, these both are radio frequency bands. Radio frequency bands. Okay, the specialty of L band is whenever you have atmospheric disturbances, when you are sending a signal onto the earth from the space, whenever you have some atmospheric disturbances, the signal could be distorted. But this L band frequency will not allow the signal to be distorted. Okay, clear signaling. Okay, whereas S band improves the accuracy of the data which you are sending. So our Indian Regional Navigation System is far more accurate than the US GPS. Remember that GPS only has L band, whereas India has both accuracy and also clear-cut information with respect to that. Okay, we are independent, there is no delay because of using these 2 bands in our regional navigation system. Now when you look at the applications of IRNSS, it has applications into disaster management, it has applications into mapping services, it has applications into marine, terrestrial and even aviation based navigation. We can track the vehicles, we can use them to integrate with our mobile phones and track the mobile phones. They are also helpful in our day-to-day life for providing precision services. As I was telling you, IRNSS has 7 satellites, 3 in geostationary, 4 in geosynchronous orbits. Please try to remember both of them. This is the infograph with respect to IRNSS. IRNSS has cesium atomic clocks, my friend, regionally developed atomic clocks in order to provide accurate timing of any picture that they take on the earth. Okay, so they are all indigenously developed maximum. Few of the satellites have failed and they were also replaced in the future missions. That is one other point which you have to remember. As I was saying you, this service go beyond 1500 kilometers of the borders of India. They have better accuracy than GPS. And I said you, there are 4 satellites in the geosynchronous orbit and 3 satellites in the geostationary orbit. Very, very important. This is one of the most prestigious projects that Indian government has taken up through ISRO. Okay, as I was saying you, these are the different regional navigation systems. USA has its GPS. GLONASS, this is what I wanted to tell you, you have to comment. The GLONASS is the regional navigation system of Russia. Next is BeiDou. BeiDou is the regional navigation system of China. Next, Galileo is the regional navigation system of Europe. And Quasi-Zenith. Quasi-Zenith is the regional navigation system of Japan. So these are all important. Now based on this technology of IRNSS, by using this satellite data, India was able to develop a new system called Gagan. Gagan is nothing but you are providing more accuracy by using ground station systems. That is, whatever data you get from the satellite, say this is our satellite in the space, whatever the data that is transmitted by the satellite, a ground station based antenna, okay, say this is our antenna, this antenna receives all this data and corrects all the mistakes. It provides accurate services that were, say in the case of timing, say in the case of position, we are improving the services and these ground based stations will provide faster navigation. They help you in disaster rescue. For example, imagine you are in a ship and your ship has happened something, a mishap has happened in the ocean and you need a rescue. And I should be able to predict where exactly your location is. And my satellite takes a pictures with the time and it has a delay in sending the pictures to the ground, right? Now my satellite data which is sent to the receivers at the ground should be able to provide me a precise location so that I can go there exactly and able to rescue the people who are stuck in the ocean, right? Such accuracy is provided by the Gagan. Gagan stands for GPS aided geo augmented navigation. Very, very important. What does Gagan stand for? GPS aided geo augmented navigation. My friends, Gagan was developed by ISRO and Airport Authority of India. Remember this. Who developed Gagan? Gagan was developed by Airport Authority of India and ISRO. Gagan stands for GPS aided geo augmented navigation system. This is another thing, as I was saying you. This is how a Gagan works. As I was saying you, there are ground staged antennas which we completely keep track on your flight, and there are also satellite data which will be looking at this flight. And if something happens, a crash happens to this flight, the immediate data will be collected by these ground stations and also the satellites to provide the accurate position where exactly the crash has happened. Okay, the major application will be disaster rescue. So now Gagan, see, when you have seen IRNSS, it only covers 1500 kilometers, whereas these Gagan services which were developed by ISRO, they go beyond the borders of India. They can serve almost half of the African continent, almost entire of Indian continent and also half of the Asian continent, and it can also provide services to Southeast Asia and Australia also. This improves the India's capability in disaster rescue in the whole region, whole Indian Ocean region, complete disaster rescue could be provided by India by using this Gagan services. Now another important thing which you have to understand is, here there is a device recently developed called Gemini device. Gemini stands for Gagan enabled Mariner's instrument for navigation and information. What is this, my friend? Gagan enabled Mariner's instrument for navigation and information. It is basically a one-way communication device which will be providing you on-site live information about the sources of fishes, about the disasters which are going to happen in the ocean. This is basically a small box. You can see this is a box. This has a speaker. You can ask for emergency services, but you cannot speak to the other person on the other side. Only the information from the center will be provided to you into this device. It is basically some sort of a speaker where all the information tells the fisherman where exactly the sources of fish are available today, or where exactly the disaster could happen, what is the wind, what is happening on the ocean. All these live informations are given. It is basically developed by INCOIS. Okay, who developed this? INCOIS. Gemini stands for Gagan enabled Mariner's instrument for navigation and information. Very, very important, my friend. This is emergency dissemination system, but it is not a communication device. This is not a communication device at all. You cannot talk to anyone on the other side by using this device. As you see, when you are going into the ocean, beyond certain distance in the ocean, you don't have telephone signals, or you don't have any signals of the phone, because there is no tower in the ocean to give you the signal. So at that moment, these fishermen have to rely on certain information that what exactly is happening, and that information will be provided by this Gagan. Who developed the Gagan? Indian National Center for Ocean Informatics Services, INCOIS, in collaboration with Airport Authority of India. They have developed this Gagan. Gemini has been developed. This Gemini, my friend, there is a second device in the Gemini also, which is the most modern device, which was recently launched. Now when you also see the basic missions of ISRO, which will help you to solve a lot of other questions. For the first mission, one you have to learn is your Chandrayaan mission. Chandrayaan 1 is the first mission of ISRO. Probably India became the first country in the world to have placed an orbiter around the moon in the first instance itself. Okay, so India was able to place an orbiter. It is basically a satellite which is going to orbit around the moon. Under Chandrayaan 1 mission, there are only two components. One, to find out the water on the moon, and this mission included an orbiter along with an impactor. Orbiter and an impactor. What is that? What happened here is, you sent a satellite attached with an impactor. So after this orbiter goes around the moon, searches for water, take the pictures of the moon, at last of the mission, this satellite will release an impactor which will go fast into the atmosphere of the moon. Moon actually does not have any atmosphere because of its less gravity, which goes onto the moon and hits the moon surface, and this satellite that is orbiting the moon will be observing that impact and will be observing what were the different components that were out of this impact. Okay, some people said that ISRO has put bombs on the moon. That's not the fact. ISRO used an impactor. It is basically a solid physical device which goes at a high speed and impacts the surface of the moon, so that you know what are the different components that are available on the surface of the moon. And remember Chandrayaan 1 mission, it was launched by using PSLV satellite system. PSLV, okay, it was launched in the year 2008 and operated till 2009. What is the major components of this mission? To find out the traces of water on the moon, to study the mineralogical composition of the moon, okay, structural, mineralogical and geological composition of the moon. Basically, it had an orbiter and an impactor. As I was saying you, there is an impactor. To study the chemical, mineralogical and photogeological mapping of the moon. There were around 11 payloads from different countries which were inbuilt into this Chandrayaan 1 mission orbiter. You can see moon impact probe. This is the impact probe that went onto the moon and hit the moon. Okay, hyperspectral imager, you have miniature synthetic aperture radar. There are 11 instruments which were included in the Chandrayaan 1 mission. No one need to know what are these 11 instruments, but just remember, all the 11 instruments were not made by ISRO itself. Different countries have provided their own input so that ISRO could successfully implement this. So you can include this data in your essay or in your interview, something like that. But remember, how many instruments? Around 11 instruments, different countries ranging from USA, UK, okay, Germany, Sweden and Bulgaria have provided services to India in order to make Chandrayaan mission a successful one. Okay, what was the mission aimed at? My friends, once again I want to say photogeology, that is to take the pictures of the moon and understand the geological structures of the moon. Chemical composition and mineralogical composition of the moon were the major aim, and also to find out the traces of water onto the moon is another aim of Chandrayaan mission. See, this is how the Chandrayaan 1 mission went through. The PSLV has launched the satellite into a geosynchronous transfer orbit, and through various maneuvers, we were able to inject this particular satellite onto the orbit of the moon. Okay, this is slingshot method, where your satellite will be rotated and slingshotted to the designated orbit. Okay, so we slingshotted. That is one important point we have to remember. So what did Chandrayaan 1 provide us? Chandrayaan 1 mission said that moon had caves. It has natural caves. So why do you need caves on the moon? Or what is the importance of having a cave on the moon? Scientists were saying that these caves, which are naturally formed, could be the best sources where the water might be stored. Or they also say that these caves will help to build human civilization on the moon. Caves are very big, right? On the earth also we see large cave systems which provide life to various living organisms, right? So in a similar way, the scientists predicted these caves could be helped to build habitations on the moon. So we were able to find out lunar caves, which show that on the lunar surface years and years ago there was a flow of lava. Okay, we were able to see the tectonic activity, how the tectonic activity has impacted or resurfaced or modified the surface of the moon, were all predicted in the Chandrayaan 1 mission. And we were able to successfully show that Chandrayaan 1 has clearly said there is source of water on the moon. Now at the point where this impactor, as I said to you, there is an impactor which went and strike the moon. At the point where this impactor has landed on the moon has been named as Jawahar point. What was the point where this impactor has gone and hit, my friends? Jawahar point. Remember, the point where impactor has landed is named as Jawahar point. The next is Mars orbital mission. India became the first country in the world to send a satellite to the Mars and successfully place it in the orbit of the Mars in the first attempt. No other country has achieved to able to place an orbiter around the Mars in its first go, and India is the only such country which was able to do in the first place. Okay. Now this Mars orbital mission. The aim of the Mars orbital mission was to send an orbiter to the orbit of the Mars, which will help you to observe different phenomena happening on the Mars. It is basically Mars observatory satellite, something like an Earth observatory satellite. You have sent a Mars observatory satellite. This satellite was launched in the year 2013. Similarly, once again, the same PSLV has been used. Polar Satellite Launch Vehicle has been used to launch this mission, that is called Mars orbital mission. Okay, what is the aim of Mars orbital mission? To study the surface feature, mineralogy and Martian atmosphere are the most important points you have to look here. And scientists were looking the presence of methane in the Mars atmosphere. Okay, if methane is available in the Mars atmosphere, we can predict that at some point of time there was life on the Mars. At some point of time there was life on the Mars. So that's one important point. So there were 5 payloads, my friend. Not necessary to remember all the 5 payloads because it is again one of the old mission. Remember, these all 5 payloads were developed in India itself. That's one point you have to remember. This is completely indigenous project. These were the pictures which were sent by the Mars orbital mission. See, Mars orbital mission has outperformed its capability. We thought initially it might work for 1 year or couple of years, but it went on working for almost 9 years, After then only it was decommissioned. That one important point you have to remember. I request you to put some effort to go and search that when was Mars orbital mission decommissioned. I need a date in the comment section, my friends. Everyone, it makes you remember what is Mars orbital mission. The same slingshot method was used in order to place this Mars orbital into the Mars orbit. Initially, the PSLV took into the geosynchronous transfer orbit. Then we performed various maneuvers, and by using these various maneuvers, we were able to inject into the Mars orbit. You can see various maneuvers were performed here from the Earth. When maneuvers, then you have sent it to the Mars orbit. Here you can see spacecraft trajectory. So that is one important point which you have to remember. And this is all about what you say predictions. We cannot go into the space and see what exactly the satellite is looking into. That is hard to predict. Okay. Now, next is Launch Vehicle Module 3 CARE mission, that is Crew Re-entry mission. Basically, this mission is with respect to the Gaganyaan mission. Okay. Gaganyaan mission, remember my friend, it's a mission to send how many astronauts into the space? 3 Indian astronauts into the space for 3 days, and they are going to be placed in an orbit at a height of 400 kilometers from the surface of the Earth. These 3 points are very, very important to remember with respect to Gaganyaan mission. Now you see, Gaganyaan mission is a mission to send 3 Indian astronauts for 3 days into the space to a height of 400 kilometers. Now in order to send these 3 astronauts for 3 days at a height of 400 kilometers per day, you need certain launch vehicle to launch it. And the launch vehicle which is being used for Gaganyaan mission is LVM-3 or GSLV Mark 3, that is Launch Vehicle Module 3, which is India's cryogenic engine based launch vehicle. Now when you are sending satellites, it's a different thing. Satellite do not need much of the protection what human needs. Human might undergo large pressures, human might undergo lot of other differences when compared to the satellites. Now what we are doing is, we were converting this LVM-3 or GSLV Mark 3, which was basically a satellite launch vehicle, into a human launch vehicle. There is a lot of difference when launching a human, when launching a satellite. So in order to protect the human and his life, we were able to modify LVM-3, and lot of experiments were conducted, wherein what if a case where this launch vehicle blasts even before it reaches the space. If it blasts, then successfully we should be able to successfully eject all these 3 astronauts and place them in the ocean where they are protected or brought back, and no life loss should be there. So in order to develop a human graded launch vehicle, all these experiments have been conducted over a period of time. We were testing all them, that is LVM-3 testing. CARE mission is about the crew re-entry mission. Okay, how safely the crew can come onto the surface of the Earth once they go into the space. Now next is SARC satellite, my friend. This is also another satellite system that India gifted. This is basically India developed this, ISRO has launched it. It gifted it to the SARC countries because India is a member of SARC. SARC stands for South Asian Association for Regional Cooperation. This SARC satellite launched in 2017 is aimed at providing various services to the SARC countries. Okay, launched by ISRO. Just remember, this is going to provide you DTH, that is direct to home services, communication services, disaster, tele-education, telemedicine services across the SARC nations. Next is Chandrayaan 2 mission. The Chandrayaan 1 mission had only orbiter and impactor, but Chandrayaan 2 mission, which was a partial successful mission, had a lander, rover and an orbiter. This is a 3 component mission. What are those, my friend? A lander, which is going to get land on the moon surface. A rover, a robotic car which is going to work on the moon surface. A lander, a rover and a orbiter. Okay, basically a satellite which is going to orbit similar to the Chandrayaan 1 around the moon to study the moon much further. Okay, this Chandrayaan 3 mission, just remember, Chandrayaan 2 mission, just remember my friend, it has an orbiter, it has a lander which was named as Vikram and a rover which was named as Pragyan. Remember what was the name of the rover? Rover is Pragyan, lander is Vikram, named after the Dr. Vikram Sarabhai, the father of Indian space research. Remember, lander, Vikram, rover, Pragyan. Unfortunately, the lander and rover failed. They crash landed onto the moon surface. Only the orbiter mission was successful. So Chandrayaan 2 was a partial successful mission. Just try to remember. Chandrayaan 2 is one of the most important mission, and Chandrayaan 2, the launch vehicle which we used was Launch Vehicle Module 3 or LVM 3. Okay, it was launched in the year 2019, my friends. Okay, it had around 11 payloads again, 5 from India, 3 from Europe, 2 from USA, 1 from Bulgaria. The aim of this mission was to discover water on the lunar surface. Okay, and to have 3D topographic maps of moon. Water to study the physical geography, to understand the geology of the moon, again to understand much deeper about the moon was the aim of us. This is the launch vehicle GSLV Mark III, which was used in the launch of the same Chandrayaan 2 mission. Okay. Same again, geosynchronous transfer orbit and maneuvering and sending it again. So Chandrayaan 2, we have an orbiter, and from the orbiter we separated a lander was Vikram. Within the Vikram there was a small robotic car, that is a rover, which is called as Pragyan. So these are different payloads which are available onto the totally indigenously developed. A small correction, this I was saying you, I might confused you last time while I was teaching you. These 11 payloads are with respect to Chandrayaan 1, and the aim of discovering the water is again Chandrayaan 1. Now I am telling you the Chandrayaan 2. This discussion is with respect to Chandrayaan 2. Chandrayaan 2 is completely indigenous, and all the components which are attached to the satellite system, say the terrain mapping camera or solar X-ray monitoring, all these are completely indigenously built systems. Okay, this is your lander Vikram. Okay, this can survive on the moon for 14 Earth days. How many days is the life of this lander, my friends? 14 Earth days. This lander has a robot inside it, that is a rover. This is going to discharge this rover slowly once it settles onto the moon. This is about 1400 kg in weight, my friends. Just try to remember. Named after Vikram Sarabhai. Lander also has certain payloads to conduct on-site experiment, that is in situ experiments. That includes RAMBA. RAMBA stands for Radio Anatomy of Moon, Bond Hypersensitive Ionosphere and Atmosphere, Chandra Surface Thermophysical Experiment, that is CHASTE, an instrument for lunar seismic activity. What happens is, once lander goes, it inserts a drill. It drills a hole and it puts an instrument which will be observing the seismic activities happening on the moon, that is the vibrations happening onto the moon surface. Next, Pragyan. Pragyan stands for wisdom in the Sanskrit. It's a small robotic rover, okay, which is going to go and take live pictures on the moon. Even Pragyan also has some payloads. These include alpha particle X-ray spectroscopy and laser induced breakdown spectroscopy. These two are basic instruments in that. So the mission was partial successful. It has provided you lot of important outputs. By its orbiter success, we have lot of success here. We tried to place this lander and rover at what point, my friend? The south pole of the moon. People say that the south pole of the moon, which is on the darker side of the moon, will provide you the knowledge about the ancient fossils and evolution of life on the earth. So again, the same thing. I have provided a lot of data for you so that you can even have a notes for yourself to keep on studying. So India became the 4th nation to reach the moon. Yeah, recently there was a current affair, my friend. India is planning to place a human onto the moon by the year what, my friend? Remember, by 2040, India is planning to place a human onto the moon. The human mission to the moon will be successful by the year 2040. And we are also planning to have our own International Space Station almost by the year 2028. We are planning to have our own space station. okay, as an international space station. You know, China is already building its own space station. What is the space station of China? Space station of China is named as Tiangong. What is the space station of China? Tiangong. Remember, China is already constructing its own space station. It is almost at the complete of that. One important point, Ritu Karidal, who is considered as Satellite Woman of India, she was the leading project director of this. It is about the Chandrayaan 2 mission. Now, one important point you have to remember here is when you are studying about the moon, knowing certain terminologies which are related to moon and its phenomena is very important. One such concept is geotail. Now what happens? Earth has its magnetic field. You know, because of the Earth's magnetic field, the harmful radiations which are coming or emitted from the sun are deflected, or it provides an envelope sort of thing around the Earth that these harmful rays never reach to the surface of the Earth. Now this magnetic field of the Earth deviates all the harmful rays that are coming from the sun. So now this deviation has created certain region in the moon's orbit where it is not being affected by the harmful radiations of the sun, and this region in the moon's orbit is considered as geotail region. Geotail is that part whenever harmful radiations or harmful solar wind is pushing into the Earth's magnetic field is compressed onto the side which is facing the sun. Now the other side will be protected from the Earth's magnetic field. This region, whole region which is being protected by the Earth's magnetic field on the opposite side of the sun is considered as what? Geotail. Remember this concept about the geotail? That is one important thing, and the description I have provided you along with the diagram. Okay, now another small concept, that is virtual positioning system. This is basically some sort of gaming system or new technology system where you will be placing yourself virtually into the maps and trying to observe everything. It is something like a Pokemon Go game. So I would like to wanted to show you that picture. What is virtual position system? This is something like that. You are virtually positioning yourself into the virtual world. Next, the last but not least, we are going to discuss with respect to the commercialization of space activities. You might have seen in the recent years, there were budding industries into the space segment, that is private industries or startups coming into the space segment. We have seen Skyroot Aerospace, a Hyderabad based startup. What is that, my friend? Skyroot Aerospace becoming the first Indian private player to have its own launcher. And this launch, it has launched its first satellite, and this launch was named as Mission Prarambh. Now what is this Mission Prarambh, or what is this importance of private players coming into the major field of space and space technology? Now you see, my friends, ISRO being a research organization, it cannot always focus on the commercial activities. Now the technology developed by ISRO, the infrastructure developed by ISRO is a fertile ground. It's basically like a fertile soil where all these budding industries can come and sit and grow at a faster exponential rate, so that it is useful for India and also for its economy, right? Indian economy and also for its public. Now what happens here is, ISRO has laboratories, ISRO has lot of technologies. We have seen none of the ISRO rocket is without any paint. Every rocket has a paint, basically a white paint. Have you seen ever that this white paint being burnt down by the fire that is given out in the exhaust pipe? No, we haven't seen it. So we can say that ISRO has developed such a paint which is fire resistant in nature. Imagine our urban areas being painted by this paint which is developed by ISRO, so that there could be no possibility of fire incidents happening in the urban areas, right? So such a technology developed by ISRO could be easily commercialized. Now who can bring this technology from ISRO, a fireproof paint, and make it in a large scale so that that paint becomes cheaper? private players itself, right? Government cannot do all these things. Government is much busier to develop policies, governance and etc. So in order to encourage the private players to take up the technology of ISRO, to utilize the basis of ISRO, you see this mission Praram, from where the Skyroot Aerospace, the rocket was sent into the space, was a ISRO's test platform or ISRO's launch pad. From Sriharikota launch pad itself, we were able to launch it, right? So that's what is important. That's what is important. So using the infrastructure of ISRO, using the technology developed by ISRO, we can make our economy grow. We can also provide employment to a lot of people. And in this cycle or in this direction, in the year 2019, government has brought various reforms and developed two important organizations. One is InSpace, Indian Space Authorization Center. This is basically interacts with the private organizations and help them grow. It falls under the Department of Space. India Space was in 2020, it was completely commissioned. It is basically an authorization center. For example, imagine ISRO has a laboratory. It has high laboratories, high-end technology laboratories. Now a private player, to test his components, a satellite maker to test his component, where can he go? Now he goes and requests this India Space, sir, I want to utilize your laboratory. And by taking a nominal fee, we are going to encourage this private player to use our laboratory equipment to develop more and more better satellite systems. That's what India Space does, allowing private players to utilize the infrastructure of ISRO. Now there came another organization, New Space India Limited. This is a public sector undertaking company, basically a PSU. What does this India Space do? India Space will be commercializing the ISRO's technologies. It is going to help for launching. It is the majorly it is going to develop SSLV, small satellite launch vehicle. These are the new age launch vehicles, my friend. These are basically SSLV, I haven't said you. These are three-stage all solid along with velocity trimming stage, liquid velocity trimming stage. Okay, this is a three-stage launch vehicle. All the three stages are solid fuel, which is used to place a 500 kg of satellite into a height of 500 kilometer. That is to place a 500 kg of satellite into low Earth orbit. These SSLVs or PSLV services, or as I said you, the paint that is developed by ISRO to transfer this technology, to transfer this knowledge to the private player, all these works are done by the New Space India Limited. Apart from these two, we also have another organization, Antrix. Antrix is initially the commercial arm of ISRO, which interacts with the world countries. That is, if America wants to take up some services of India, or America wants to launch a satellite from some launch vehicle that is going into the space, if we have enough space into that, we can accommodate USA, we can accommodate Europe, any other country's satellites. So such services were provided by Antrix. Antrix was launched in the year 1992 and it is presently a Mini Ratna company. This is also a PSU. All these are under the Department of Space. Now apart from that, India has also announced lot of FDI policies where it opened the space segment, where the foreign companies could come and invest into the Indian space segment. Okay, what are those FDIs? We will be discussing in the current affairs topics. So this was your commercialization, my friends. Space is a larger economy, my friends, almost $360 billion industry. Of this $360 billion, India has a mild share. US has the highest share. India has only mild share of just 2% of this $360 billion. Imagine if we are able to increase to the 10%, that is $36 billion. $1 billion is almost 8,000 crore rupees in India, 8 to 9,000 crores. Imagine we have $36 billion. How much of money will be coming into India, how much of employment that we will be able to provide in India is very, very important. And the space segment is growing at a faster rate. For that purpose, India should keep on investing or keep on encouraging the private players. As I said we developed Indian Space Promotion and Authorization Center and New Space India Limited. This is focuses on R&D and scientific mission and space exploration. This provides with commercial activities. This is your Indian National Space Promotion Authorization. This is a non-government private entities. All these private entities come and interact with IN Space, which will be providing a single window hub to the premises and infrastructure of ISRO. So, all those points I was able to provide in these slides, which you can keep on looking and keep on revising for the purpose. This is New Space India Limited. It is a PSU basically developed under Companies Act of 2013, launched in the year 2019. This is Antrix. These are the services provided by the Antrix, ranging from satellite services, ground system services, spacecraft testing facilities, spacecraft subsystems. This is basically interacting with the foreign countries. Okay. So, FDIs we will be discussing in the next class with respect to the current affairs, and the other thing what we will be discussing is a new class with respect to the space. So, I hope you are enjoying our classes. Keep watching, understand the basics. Please keep commenting in our session so that we can improve ourselves and provide you better and better classes. So, the PPT will also be available with you. Hope you are enjoying. Thank you.